Hey everybody, in this lesson we're going to talk about experimental uncertainty. Even with all precision and being precise, we will still get a range of values due to experimental uncertainty. So what is experimental uncertainty? Well, when you measure an object, the last value is estimated. When you measure, the last digit is estimated. Because of that, there's a range of estimates. So for example, if you say something is 10.65, it can also be 10.64 or 10.66. So because of that, we have what we call experimental uncertainty. There's some uncertainty here. So how does experimental uncertainty work? Well, we use a plus minus after our measured value to explain range, to explain the uncertainty range. So what does that mean? Well, an example. If we write 21.45 plus or minus 0.02, for example, what this means is your value can be any number from 21.43, 21.44, all the way up to 21.47. There's a range of 0.02 for that value. So that's an important part. Now, if this range is not given, then if we have multiple measured values, it's always half of the range. So if no range given, then it is the halfway point of your measured value. Now, what does that one mean? Well, for this one, say for example you measure something to be 45 and 0.0 and 46.0. How do you find what the halfway point is? Well, the halfway point is if you take 46, take away 45, you get 1. Now to find the halfway point of this, you divide that value in half, which means it's 0.5. So your range ends up being 0.5. So what do you put then? Well, because your range is between 45 and 46, what you have here is the midpoint is 45.5 plus or minus 0.5. Because if you add 0.5 to this value, you get 46. If you take away 0.5 from this value, you get 45. So as always, the midpoint of the two values plus or minus the half half of the range. The range being 1 here. So how do we create our own uncertainty from our measurements? Our uncertainty is always based on the last digit. And to find it, if it's not given, it is usually or always 1/10 the smallest unnumbered division. Of an equipment. So whatever equipment you use, the uncertainty is usually 1/10 of that smallest value. So what does that mean? Well, what that means is, an example, is if the smallest the unnumbered division was 0.1. So unnumbered division, the smallest one, was equal to 0.1. Then the uncertainty is 1/10 of that, which means it's 0.01. So it'll be plus or minus 0.01. If it's 0.2, the uncertainty will be 1/10 of 0.2, which is 0.02. So what happens when we add and subtract values that have uncertainty in it? AKA you were trying to add two beakers together, you have to add their uncertainty. What happens? Well, what we do here is we add their uncertainty as well. So what does that look like? Well, if you look at it here, this example, we have 22.6 plus or minus 0.1 plus 36.5 plus or minus 0.1. In this case, we add our two main values first. So 22.6 plus 36.5. This gets you, 59.1. Now what is the uncertainty? You also add these uncertainties too, because your range of answers can be now, instead of 1.1 of a centimeter in range, it's now 0.2 of a centimeter, because you could be minus 0.1 here and minus 0.1 here, which means your value is actually minus 0.2 centimeters away. So that's how you deal with uncertainty if you're adding or subtracting them. Okay, how does this relate to significant figures? Well, this relates to significant figures because what you're dealing with here is that you're dealing with values based on precision and accuracy, and these significant figures are values that you know we can trust. So we're going to deal with two different ways with significant figures. One is multiply and divide, the other one is add and subtract. What do you do with sig figs if you do orders of operation to them? Well, when we do operation with sig figs, we need to round to correct sig figs. And this is due to the experimental uncertainty that affects your last digit. So what is the rule of multiplying and dividing then? In this case, when you multiply and divide sig figs, you always, for this one, when you multiply and divide, because division is just a reciprocal of multiplication, you round to least number of sig figs. So let's practice that. When you look at this question right here, 3.534 times 131. If you punch this in your calculator, you will get this number, 3.534 times 131. You get 462.954. So this is equal to 462.954. But as we noted, these last digits are rounded. And because they're rounded, we can't trust them as much. So we want to make sure we can round this answer here to the correct number of sig figs. Well, the rule of multiplication and division is you round to the least number of sig figs in your question. So it should be in your question. So in this case, our smallest number, well, this one is 4 sig figs, this one is 3 sig figs. We should round it to 3 sig figs, which means this number should round to 463, because it's 2, which are our third sig fig, will round up because it's 9. Okay, what about the rule of addition and subtraction? What do you do with sig figs here? In this one, you round to not the least number of sig figs, but of decimal places, because when you add and subtract, you're not dealing with decimal places in their place values. Okay, the reason why is because The less decimal value is more accurate, as you cannot estimate beyond that. And I'll show you that with this example here. So in this example here, you have 3.23 plus 1.2. So if I write this out, 3.23 plus 1.2. So if I were to solve this, the reason why if I were to solve this, it would be 3, 4, 4. But I want to round to the least number of decimal places. This one here has 1 decimal place. This one here has 2 decimal places. I want to round to 1 decimal place, which is why it should be 4.4. Now, why is that? It's because, let's look at this right here. The hundredths place for this value here, we don't know. It could be any number. It could have been rounded to 1.2. We cannot assume that this number here is a 0. It can't be. Instead, what we can assume is that it's some value. We know that, but we don't have to take the 3 into consideration in a sense. Once we solve it, we round it to the least number of decimal places. So that's why it can only round to 1 decimal place in this case. If I look at this next example here, same thing. If I look at 19.45231321, take away 1 point, oops, let me put in correct place value, 1.423. Again, we cannot estimate that these numbers here are zeros. We just can't. We are assuming that these numbers are rounded. And because that's the case, we can't really do that. So instead, we just punch our calculator and make sure we round to, in this case, 3 decimal places. So what we have here is we have 19.45231321. Take away 1.423, and we should get 18.029. So 18.029, 3 decimal places. So you always want to make sure we punch everything in, even though, yes, we know that we aren't taking these decimal places into consideration. We still want to use them just in case. We don't want to round too early. We always only want to round at the very end. Our last example we're going to talk about is what happens if you have multiple operations, like BEDMAS. In this case, what we got to do is we got to perform each operation without rounding. That's the first thing we gotta take care of. So do not round until the very end. Round at end. But what you gotta do is keep track of sig figs per each step. Okay, and I'll show you that with our example we're going to work on. What does it mean keep track of sig figs per each step? Of course, step 3 is use BEDMAS still. So when we talk about multiple operations, we're talking about BEDMAS. So let's take a look at this example below. We have 9.34 times 0.07146. Take away 6.88 times 0.08115. In this question here, we have multiplication, and we also have a subtraction. In BEDMAS, we gotta do multiplication first. So we should multiply this number together first, okay? And then we should make sure after that we should multiply these two numbers together before we subtract them. Okay, so let's do this one first. When I multiply these two numbers together, 9.34 times 0.07146, I get 0.667, so 0.667 4364. 4364. Okay. When I perform it on this one, so 6.88. 6.88 times 0.08115. I will get this number, so in this case, 0.558312. And of course, I have a subtraction I still need to perform. But I gotta make sure I keep track of sig figs already. Because if this red box question was just its own question, I would have rounded this question to the correct number of sig figs. Same with this blue box. If this blue box here was just its own question, I would have rounded to its correct number of sig figs. Here, in this red box, I have the least number of sig figs I gotta do is multiplication, is 3. There's 3 sig figs here, there's 4 here. That means if this was its own question, this would round to 3 sig figs. So what I want to do to keep track of my sig figs, that's what I mean, I usually underline what the correct number of sig figs should be, which means that this number should have been rounded to 3 sig figs. That means these 4, 3, 6, 4 here are not trustworthy in a sense, but we should keep them for rounding purposes. Over here, we do the sig fig calculation again. Here, we have 3 sig figs. This has 4, so this should round to 3 sig figs, which should be here. But again, I don't want to round until the very end. So I want to keep these values after my sig figs because they're still valuable. So what I have here, last step, take away 6, 6, 7, 4, 3, 6, 4, take away 0.558312. And I get 0.1091244. 0.1091244. Now what's the rule of sig figs when we're subtracting here? Well, it's least number of decimal places. Well, if you take a look at here, this doesn't actually have 7 decimal places. This actually doesn't have 6. It actually has 3 because we're keeping track that there is actually only 3 sig figs here. Because, if this was the only question, I would have rounded to 3 sig figs. Same with here. I would have rounded this to 3 sig figs, so we end up with 3 decimal places here. 3 decimal places here, 3 decimal places here. When you're subtracting, it's the least number of decimal places, so we end up with 3 decimal places our answer. So I should only round up to there, which means my answer is 0.109. So make sure if you have any questions about this, you gotta practice this on your own, because practice makes, in a sense, you could say perfect, but practice makes it so you get better at this. As always, make sure you keep yourself safe and healthy, and I'll see you soon.